9.4 I had started with you all children. Let's see a few more examples to understand it better. Question number 4 till 3 I had done for you. Sec square x tan x dx plus sec square y tan y dy is equal to 0. Okay, so what are we going to do is we are going to take one of the factor to the other side of the equation. You had a 0 here, so I have taken this factor to right hand side, so that one side we have dx and the other side we get a dy. Then obviously with dx we'll have all the whole entire function of x, and dy should have entire function of y. So we'll rearrange this. Tan y will be taken to the other side, goes to the denominator. Likewise tan x removed from here, the other side it will come in the denominator. Okay, now I've cut it short here. If you all have practiced your integration enough, you know what is happening out here. We know that derivative of tan x is sec square x. So if you put tan x is t, then sec square x dx is replaced by dt. तो ये function आपका बनता है dt upon t. तो integration of dt upon t, 1 by t dt rather, is log t. Putting back the value of t was tan x. So log tan x. तो मैंने सीधे shortcut में सीधे लिख दिया है. Okay. So as soon as I see anything in the denominator and its derivative in the numerator, then this comes as log of what is in the denominator. यही form आती है. तो अगर आप, if you are thorough with that, you can do it directly. Otherwise, you'll have to show your substitution and do all that. Okay. Likewise, this side also it was the same story. Function and its derivative in numerator. So it will be log of what we have in denominator. And I had already told you कि जब ये log के terms आते हैं, then we take the constant also as log so that we can merge and simplify the result further. So I have taken log c as the constant. Always constant has to be there when we are dealing with differential equations on integrating. Okay, then this I have taken to the other side of the equation. Minus sign was there. Taking here, this will become plus, and when there is plus, log m plus log n, log is m into n. We multiply the numbers. Okay, so that is why I have got log tan x into tan y, taking this term the other side. Okay, and log c. So now your log and log balances, so you have your resultant as tan x into tan y is equal to c, is how you'll leave your answer. Okay, then in the fifth one, again you had this whole expression here with dy, and then this expression with dx and 0 the other side. So again you can take this whole factor to the right hand side. Okay, so that is how it will come. And then after that, putting x with x and y with y. तो entire function x का है, देखो y के साथ y का कुछ नहीं है, तो 1 times dy हो जाएगा. Okay, so integrating 1 with respect to y gives you y, and ये आपका जो यहाँ numerator में है, again this will come to the other side in denominator. So this is derivative of what we have in denominator. See, if you put e to the power of x plus e to the power of minus x as t, differentiating, derivative of e to the power of x is e to the power of, and derivative of e to the power of minus x would be e to the power of minus x into minus 1. So ये पूरा जो भी यहाँ पे expression numerator में है is again derivative of what we have in denominator. So again log form आ जाएगा, log of this. Okay, after substitution. If you want, you can check it. Okay. So अब इसमें एक ही term log का था and y already आ गया था. As we have said, most of the time we prefer to write y as function of x. Okay, so इसको मैंने as c ही छोड़ दिया है. If you want, you can take it as log c and merge it out here and convert it to exponential form. Already यहाँ पे e है, तो उतना वो expect नहीं करेगा आपसे कि आप उसको भी exponential में डालो. Right? You can leave it. I hope you're following what I'm saying. I'm just saying he may be, again in the exam at times they can ask you to change the form. You should always know how to change the form. Okay, क्योंकि ये log का term था, तो we could have also continued this answer as y is equal to log of c into e to the power of x plus e to the power of minus x, because I can take this as log c फिर merge करके, and अगर ये आता है तो उसको फिर आप further log भी हटा सकते हो. You can write this as e to the power of y now, whatever is this base raised to this power, and is equal to c into e to the power of x plus e to the power of minus x. If required, आप ऐसा भी आंसर छोड़ सकते हो. Even that is a perfect form, because usually we write function as y in terms of x, so y as something, perfect answer. But कभी कभी इसमें proof का problem आ जाता है, तो you show कि इसका if this then this is the relation. Okay, so you should know how to transform. That's why I just introduced that point to you here. Okay, then the sixth one question, children, was like this only. dy by dx is equal to this again we will put function of y with dy and x with x. So if you do that, this goes to the other side, it will come in denominator naturally. So we will have 1 upon 1 plus y square to be integrated with respect to y, and here 1 plus x square will be integrated with respect to x. Okay, so getting this to the left hand side, taking this, getting this to the right hand side, taking this to the left hand side. This is what your function becomes. Now integrating both sides. So integral of this is, we know that's your standard result, tan inverse y. Integration of 1 is x, integration of x square is x cube upon 3 and plus the constant of integration. आप आंसर ऐसे भी छोड़ सकते हो, या y is equal to इतने पूरे का tan, but tan के अंदर इतना बड़ा expression लिखना is not advisable, so leave your answer like this. Okay, then in the 7th one we had y log y dx, and I think it was given with a minus sign there. I've taken it to the other side. Minus of x dy. 0 tha, so naturally first step would be to take this to the other side. So I've taken it as x dy on the right hand side. Now with this x goes with dx. So that would become in the denominator 1 upon x dx, and with dy I would have this also in the denominator. Okay. So first thing, taking x dy to the other side and then putting x with x, y with y, rearranging, this is what you get. And clearly this is integral. Integral of this is log x, and integration of this would be log of log y. Again the same thing, हमें पता है कि 1 by y is derivative of log y. So if you put log y as t, इसका derivative 1 by y dy would be replaced by dt. So we have this dy and 1 by y being replaced by dt. So you are left with 1 upon log y we had said is t. So ऐसा कुछ होता है. You've done number of times in integration these kind of things, solving integral by substitution. So its integral comes out to be log t. T was log of y. So ये मैंने यहाँ shortcut कर दिया था सीधे. It's up to you. If you can do it straight away, well and good. Want to show the working? Nothing like it. Okay, so yes, now log and log either side would get balanced, and this is constant of integration, children. You can take it on the right hand side or maybe on the left hand side. So पहले मैंने इसे log c यहाँ लिख दिया था, but then I wanted to release y, so I have taken it to the other side of the equation. Okay, say let's call this one as c dash. When it goes that side, then that will be merged with log x plus log y, log x प्लस log c हो जाएगा इधर की तरफ. ओके, दैट माइनस साइन, वो तो कांस्टेंट में कुछ फर्क नहीं पड़ता है, नेगेटिव हो पॉजिटिव हो, इट इज एनी कांस्टेंट. ओके, सो वी कैन राइट इट एनीवेयर, दिस साइड दैट साइड, इन डिनोमिनेटर इन न्यूमरेटर, सो जहाँ कन्वीनियंट हो. सो आई हैव मर्ज्ड इट, log of xc हो गया ये by properties of log, and then here you had already log y, so again your log and log is getting balanced. So now ये ऊपर भी मैंने आपको already explain किया था, xy or xc is equal to log y. So if no base mentioned means base is e. So base to this power should be value of y. Okay, so ये log हटाते हैं, from exponential form to log, log to exponential form. So this would become your answer.